All right, welcome. It's been a fun few days, so I appreciate seeing you all here. It's late in the conference, so thanks for joining. So I'm Jussi. I come from a company called Kontena, where we've been building things on top of Kubernetes for the past year and a half. Today I'm going to talk about a bit how we've been building and maintaining a Kubernetes client library, and actually sort of swimming a bit upstream because we've been doing it with Ruby instead of the Go as everybody else in the cloud native world is doing. So it's sort of a storage from the trenches type of thing where I go through a couple of the, well, few of the pitfalls we've fallen into. I'm going to start by going through a bit of the sort of background why we actually started to build a new client library for Kubernetes. We'll go through some authentication bits from the client, purely from the client point of view, how it's well, it's a bit hard, or at least a lot harder than it seems at first glance. Then we'll go to bit about the posting, putting, patching of resources, and few words on different types of merge patch styles which you can use with Kubernetes API. And then at last we'll talk a bit on CRDs, these custom resources, and how they make or can make life difficult from the client point of view. So I hope I'm not able to put too many of you into sleep in this session. So yeah, this is a bit like story of how many pitfalls we could actually be able to hit during our journey into the client world of Kubernetes. Unfortunately, there's not really enough time to go through every single one of them because trust me, we've hit quite a few of them. I'll try to select the sort of most important ones if you're thinking about writing a client library, or if you have to work with the sort of low-level API things with Kubernetes. Of course, if you're just using kubectl apply, then all of this might not really apply to you, but it might help you actually understand how things work with kubectl, how they do. So yeah, at least in our cases, when we started the journey, we really underestimated the effort, what it actually takes to build a truly working client library for Kubernetes. But on the other hand, it was really a good learning exercise for us too. So now we really understand how Kube API works and why it works as it does. And in the end, it really is now a sort of enabler for us and our teams to build different things on top of and using Kubernetes API. But as on the slide, do not really underestimate the effort and do not really start to do it unless you know you really have to do it. So as I mentioned, we've been building this sort of a Kubernetes distribution called Pharos for the year and a half already now. And as part of the distribution, we actually set up hundreds of different resources on top of the cluster, the core Kubernetes cluster. And of course, when you manage that number of resources in the distribution, you really have to have something lean and mean to operate on. And as the trend is now with Kubernetes, there's a lot of CRDs and custom resources that's created for different operators and different other building blocks in the cluster. So we really wanted something that can also easily work with CRDs. Out of those 400 resources, we provisioned like storage classes, different CRDs, ingresses. We deployed backup functionality with Arc and those sort of things. And of course, basically everything I'm talking about is open source, and the main one being the K8s client that we have. So it's under Apache 2 license. Pharos cluster is also the open source, and it's the sort of main user of the client library. On top of the client library, we've also created another sort of deployment tool called Mortar, which helps you manage resources and this complex set of resources. And those are just mainly as an example of the users of the client library we built. So you can go and look how we use the client library, and there's a lot of good examples how to use it when and if you need to use Ruby or want to use Ruby. So let's begin the journey, and for us it ended up being a bit more dark themed than we anticipated. So to really understand how and why things work in the API as they do, first we had to really understand how the request processing goes in the API. So every single request on the API server is of course authenticated. There's a lot of different plugins that you can configure on the API server, and basically the first one successfully authenticating the user passes then the identity forward to the later stages. Authorization, typically RBAC, then authorizes whether I'm really allowed to do what I'm trying to do. And after that, there's a set of admission controllers which can do things on your resources. Admission controller can reject your resource that, oh, this looks too dangerous, I'm not going to allow it in. Or it can actually mutate the resource, put on some default values, change things, and so on, and then after that, pass it on. The last step is actually validating the resources so that the pod you're trying to create is actually a valid pod. And then only after that, we store it on the etcd data store, on the API. And then when it's on the etcd and then available on the API, then there's a lot of other controllers actually creating reports and replica sets and whatnot. Authentication, the first step in the request processing, it's, well, from the API server point of view, it's pretty straightforward. From the client point of view, it's actually not. On the API side, it's basically three ways which you can authenticate: client certificates, tokens, or HTTP plain authentication. Of course, for tokens, there are a couple of variations, but it's still essentially a token authentication. So pretty straightforward. Well, it turned out that the KubeConfig, which is used to configure the client side, has actually X number of ways to configure authentication. And I really mean X because I have a gut feeling that we haven't seen all of them yet. Some of weird corner cases has been popping up every now and then, and we just have to try to support them. And one of the troubles in the authentication part is that actually, in many cases, especially for managed Kubernetes like EKS, GKE, we have to call an external tool to get the token to pass on to the API. Just as a couple examples, the top left corner is from Google, and you actually see that there's a configuration to call the external tool to some JSON path to the output of the tool, and only after that you get the token to be passed on the API. Well, it's not that difficult to support. We can pull it off. Well, then came EKS, which uses pretty much the same sort of style and idea. We call an external tool, we get the token, we pass it to the API. But if you see, the configuration is totally different on the KubeConfig. So yeah, let's build a support for that too. Well, on the right-hand side, those are the most typical ones you see. There's a plain token already on the KubeConfig. We just pass it on to the API, or there's a client certificate. We put it on the request, and it just works as it should. So that also led to some other complexities on the kubeconfig part. The kubeconfig, the environment variable, can actually point to many different kubeconfig files. And luckily, it's pretty well documented how the client is expected to sort of merge the information, but the merging rules are actually pretty complex. And then when you have a lot of different clusters, which all of you have named a test cluster, a test cluster, a test cluster, the merging can be, well, hard or undoable even in some cases. I learned not to name all of my clusters like test clusters. So now I have test cluster 1, 2, 3, and so on. One of the oddities we've seen also is that in some cases the token in the kubeconfig file, it can be or it might be or might not be already base64 encoded. And that's a pretty difficult thing to figure out whether I have something that's already base encoded or not. So we've had to do some workarounds for that too. And then, of course, the configuration is somewhat different whether you're running out of cluster on my CLI or whether I'm running this thing on a pod within the cluster. So we try to support everything. And then, of course, from purely, if I see myself as user of this library, the user shouldn't really have to deal all about this complexity. So what we've actually been now able to do is that. So we've tried to hide all the nasty details from the users of the library. So just KDS client autoconfig, and I get a client instance back. So that's pretty neat. OK, let's start to work with the resources. Now we have the client that we can actually use to talk with the API. Let's start to actually do some resource things. So of course, as we developers always do, we start with the sort of simple, naive approach. And of course, that's what we did do. So to be able to create a resource, you do a post on the API server to the given path of the resource, and voila, you have a resource on the API. Then when you need to update it, you get it, you reconfigure it, and you put it back, as you do with the normal REST APIs. The merging usually happens when you load a local YAML file, let's say a pod, and then we merge it with the resource that we got from the server, and we try to put it back. This actually works pretty well in most of the use cases. And a lot of the different client libraries that I've checked, they actually use this approach in them. The official, or not official, but the Go client doesn't use this. And you'll see in a couple of slides why. The local merging can be actually problematic when you have deep structures and arrays and everything in your YAML. So that might become actually a bit complex. So we started to think that, OK, why can't we just basically load the YAML file from the disk, a pod, and why not just put it back to the server as is? Well, it turns out that what you have in your local YAML, and if you compare what you have on the server side, they're not even close to being the same resource. So there's a lot of defaulting happening in the API, where when the objects are marshaled from JSON to Golang and back to JSON to etcd. And also remember that on the request stages, we have these admission controllers, which can actually mutate your objects. So what you have on local disk and what you have on server, they might or might not be the same thing. Of course, you should have pretty much same attributes, but usually on the server side, you have a lot more default values and those sort of things. So essentially, when you load up the YAML from a disk, you try to put it, the server just says that no can do, can't accept this, not valid. So this has led basically to have this sort of a different ways to actually patch resources on the server. And what what the Golang library does is this sort of a strategic merge patch, which basically is a server-side merge of the resources. The problem in that is that the strategy used to merge things together is actually decided on the server side. So the result might be different if I'm updating a pod versus if I'm updating a custom resource. So the logic can be different. And for example, if I have a pod existing already on the server, and on the local one, I replace a container in a pod and do this strategic merge, on the server side, I end up having two containers in a pod. So for example, arrays are merged and not replaced, by default at least. So we started to use this. We ended up having, again, some trouble because the merging didn't work as expected. What we actually ended up doing is pretty much what kubectl does when you do a kubectl apply. So essentially, it's a sort of a three-way merge on the client side. So whenever we create a resource with the client now, we record the last applied configuration in an annotation. So basically, we record what we saw last time when we loaded the thing from a YAML file. Then we get back the resource. We look at the annotation that this was the last used configuration, and then we do basically a sort of a three-way merge. And then we patch it with a specific JSON patch content type on the server. So essentially, it's pretty much saying what kubectl does on apply as mentioned. Well, kubectl doesn't actually use JSON patch, but it does pretty similar thing anyway. So the JSON patch is basically a diff between what we had and what we have from the local, what we have on the server and what we had on the disk. And that diff is sent with the application JSON patch headers or content type. The nice thing with JSON patch is actually that it's defined in an RFC. So there's not much room for interpretation. It should work as it's specified because, well, it's an RFC. Well, turns out that we would have liked to be able to do some interpretation in that, but that's another discussion, maybe. So essentially, a JSON patch is a set of operations. Remove this key from the document, from the resource. Add this key and with this value to the document. Replace this key with this value in the document. So it's pretty actually describing what the end result should be. Just to note that all this complexity on the client side is probably going to go away in some time frame. So now in 1.14, the server-side apply is on alpha stage. So it's under a feature gate that you have to specifically go and enable on your API server. So it basically means that all this merging logic and all this pain is actually handled on the API server side, which is super cool and nice for the client libraries. But of course, as a fully generic client library, we just cannot jump into using that sort of a thing because, well, you cannot go and enable that on EKS or GKE. And of course, our library should work with, well, older version of Kubernetes. I think it still works with 1.7 Kubernetes even, if anybody is using that old version. One thing we sort of struggled a bit with is also this empty versus null versus undefined thing, which if anybody's using JavaScript, you probably bump into similar things. And so I have a resource, a pod, where I don't have labels, I don't have ports or anything defined. That's fine. Then I create another pod where I define labels as an empty struct. I define ports as an empty array. When you post those two ports into API server, they end up being the same, which is okay. I can live with that. Well, as it turns out, it's well, they are the same until they really actually are not the same anymore. So as we are using this JSON patch to add and remove these keys, so we can do a JSON patch and add a key as an empty value to the API. Well, the API says, yeah, done, it's there. Okay, then we try to add another value with the same key, and it says that no can do. There's no such key here. It's like, okay, what the F? But it turns out that, well, the API server just basically filters out all the empty values. So it's like a bit of a limbo whether something is empty or missing or nil, or it's just not there. So empty is not there in Kubernetes. Which is actually pretty problematic, because in some cases empty might actually mean something. Like, for example, in network policies, empty actually does kind of mean something. And then in your custom resources, well, we don't know what the resource is. Empty actually might mean something. So it's a bit of a pain to do that or work with that. So with JSON patch, you basically have two options. You can either drop all the empty values or empty keys from the sort of the last applied configuration annotation, which we record on the objects. Or then you can deal with the empty values when you're actually sort of calculating the diff between these two different versions of the resource. What we ended up doing in the K8s client is we actually drop empty values from the annotation where we record the last applied configuration. And that has been working really nicely for us, at least in this version of the client. But I'm sort of pretty sure that we'll hit some problem with that too in some time frame. All right. Just a quick sip of water to keep my voice going. I've been on a booth duty the whole conference, so I'm a bit lost in voice. So sorry. Okay, so how does the client actually know to which HTTP endpoint it should post or patch the resources on? So in the API, there's this discovery mechanism. So there's a specific API endpoint where you can call and you basically get all the API information. The API understands these sort of resources, and these are the API endpoints you should be using to access and control those resources. And the same mechanism is, of course, used for CRDs. So when you create a new or sort of register a new custom resource, the API will then, on the discovery API, tell that, OK, there's this new type of resource, use these endpoints to control those resources too. So it essentially gives you a map of for these kinds, use that endpoint in a nutshell. From the client point of view, you have to think whether you want it the client to really have a static mapping of certain types of resources to the certain endpoints, or do you really want it to be fully dynamic? I mean, with dynamic, I mean that the client actually understands and is able to reload all these API discovery information from the API server. And then one thing you have to think about also is caching, whether you want to cache that information somehow. kubectl, for example, caches a lot of that information on disk in your home directory .cube.something. And of course, on caching, well, there's two hard problems with computers. and I think one of them was cache invalidation, if I remember correctly. So what we decided to do is no caching, because, well, that just opens up a Pandora's box always. So whenever you boot up the KDS client, it basically does the API discovery on the fly, and it's just able to work with any custom resource on the fly. It also, of course, does mean that there is a sort of a performance hit on that, because it has to do the discovery API calls. But in our case, it hasn't been too bad at least, so we've been able to pull it off still pretty nicely. Well, has anybody been working with the Go client and CRDs? Yeah, few hands. I guess you felt the pain in doing that. At least whenever I have to work with the Go client and CRDs, I sort of end up shaving yaks for the next couple of days, and it's sort of painful. So we started to think whether we should sort of generate the sort of stubs on the client side for the known types of resources, so that on the client side I could actually say, and I really want to create a pod now, and the client would understand that it's really a pod. We did a sort of a experimentation on that, and actually we ditched all that, and the client doesn't understand anything about the resource kinds. It just understands that it's a resource. So in our case, and especially now with a lot of CRDs coming into the picture, it's super easy for us and with the client, because, well, we don't have to do anything to work with CRDs. It's just another resource. And it's one of the sort of main building blocks behind that is a Ruby gem called recursive open struct, where you can basically have a Ruby hash, and it sort of objectifies that, so that I can actually call just plain object methods on any given resource. Whether it's a known pod or some new CRD, it just works the same way. So just as an example, to create a CRD resource, you just create a resource, put all the basically what you see on any given YAML file. You define that what's the API version, what's the kind, and all the other needed details as a Ruby hash, and voila, you have a resource. You can just now go and create it on the API. You don't have to go and generate the stubs or anything for the custom resources. You don't have to figure out how do I actually now register these custom resources and APIs into the client library or anything like that. So no yak shaving anymore. And then if you want to just go and get some custom resource, you load up the client with the one single autoconfig method call. Define what's the API of the or the API version of the resource you're getting, the type of the kind of the resource, and the name of the resource, and voila, you have it. Again, no CRD registrations, stub generation, or anything needed. So especially for us, this sort of generic resource has been working really well, and hopefully someday somebody comes with something similar for the official Go library too. I'm not that super guru on Go whether that's actually doable or not, but maybe somebody after the session can enlighten me whether it's possible or not. So those were the sort of main pitfalls that we fell into. Hopefully that gives you some idea of which traps to try to at least avoid, and hopefully none of you fell asleep. So there's a few minutes for questions. if you want to ask some questions, and if not, I'll be hanging around a bit after the session. You can have a discussion if you want. So. Thanks. Yeah. I don't know is there any microphone that we can use for the questions? Thank you.
Thank you. Am I right to understand that the client that you created is not compatible with the kube control client? Because what I mean by that is, in order to be able to do your patches, you had to put some extra labels on your the things that you are deploying. So if I had deployed something with kubectl and I tried to do a patch with your new client, that would not work.
Well, it actually works because kubectl does the same thing.
Okay. But that's not documented, yeah. Well, that's by chance.
There's a special flag on kubectl, the --save configuration or something, which actually does it. So, yeah, in our main use cases, we always use the same client. So for us, it works pretty nicely. But it should work with kubectl too. You just have to remember to use this --save thingy. Can't remember what's the flag's full name. There's too many flags on kubectl, so. Here's another one.
Oh, sorry.
Hello, thanks for the great talk. If performance was not a problem for you, as you seem to imply by the fact that you're rediscovering everything every time, did you think about just like using kubectl behind the scenes? And why didn't you do that? Or
yeah. So the simple reason why we didn't use kubectl behind is that the other tooling for the distribution, the main thing that we're working on is Ruby tooling. So we didn't want to sort of from Ruby to fork out to kubectl and fork back and those sort of things. So it's still sort of in tree and works within the same process. So that's the main reason why we didn't do it. We actually did think about it, but we didn't want to do it. Because then the users would have to not to download just our tooling, but then they had to have also kubectl and everything in place. So it's simpler for our use cases to do it this way.
Perhaps it's a bit of a weird question, but did you do anything with the port forwarding API in Kubernetes for local host and that kind of thing?
No.
Okay.
We haven't tried it, but yeah. I'm probably pretty sure that it doesn't work. So
yeah, it's a bit of a strange protocol, I think. We tried doing it, but it was quite difficult.
Yeah. But if you have a good idea how it could work, then please do a PR. Yep.
How about Watch informers?
Yeah, it supports Watch. Yeah.
How widely is this used? Is it only used by your projects or this Kontena?
I think our projects are the main users, but I do know a few other users also, and we've received a couple of sort of external PRs also. So it's great in that sense. But of course, we'd be more than happy to see more using of our tooling and more PRs and issues and everything. So
like I maintain this PyCube Python client, which is originally by someone else, but now I like maintain it with this NG because it was unmaintained. And the official client is, for me, it sucks because it's not Pythonic and it's 21 megabytes in the Docker file with all dependencies. So if anybody looking for a Python client and want to help me, so I use it everywhere. But there is this kind of always the question how much like high-level functionality you want to add. And for example, there was previously some high-level functionality for scaling and so on. So I want to remove it or partially already removed it because it's harder to maintain. Do you add any high-level stuff? And
we really try to avoid it. And there has been actually a couple of issues where people are asking that features like, okay, I have this deployment, maybe I could have a flag where there's some force flag to force the deployment actually happen every single time, whether I've changed anything or not. But no, we don't really want to understand that it's a deployment. So we essentially try to actually avoid those sort of cases. Because as I said, it just creates maintenance headache and everything. So we try to keep it as bare bones and generic as possible.
Going back to the annotation approach, and this may be a little bit beyond the scope of this room, actually. The API machinery group may be able to talk about this more. Have we considered adding just some sub-resources to track history? Get a previous version?
Not really, because we sort of understood that kubectl does it too, and tried to be compliant with that. And also the fact that we had a discussion with, can't remember who it was, but about the server-side apply thing coming anyway up. So in some time frame, we'll be able to ditch all the client-side logic, hopefully anyway. So we didn't want to go that route, because that's then another set of resources and everything, and it sort of complexifies a bit. All right. Thanks for joining. Have a good, safe trip home.